.0075. Very good, Siddharth. Thanks. What about the sulfate? Same thing with the sulfate. It gets diluted. 125 times 0.04 divided by 200 ml.
0.0.
Are we done?
You think we'll be?
We wish, but no.
Whenever you think it's done, there's always more.
Wait,
It keeps on
we have to
coming.
concentrate.
The question is, what are the concentrations of barium and sulfate in the solution? Well, they're there. There's a concentration of barium. There's a concentration of sulfate. It's like we should be done.
Psych! You thought-
Yes. If you look at this thing, these concentrations. Now, I'm going to do a very crude calculation. I'm going to look at this and say, okay, this number is 10 to the negative third. Right? 1, 2, 3, 10 to the negative third. This number is 10 to the negative second. So 10 to the negative third times 10 to the negative second is about 10 to the negative fifth. The KSP, so that would be Q. Q is 10 to the negative fifth. K is 1.5 times 10 to the negative 9. Is Q greater than K? Yes. So a precipitate forms. It shifts back this way. How much does it shift back that way? That's what I'm telling you that I want you to do. Now, does it go all the way to the left and then stop? No, because if it goes all the way to the left, one of these things is going to run out and it won't be at equilibrium then. But we're going to do as I mentioned up here. Allow it, assume the precipitation goes to completion. So you're going to take it all the way as far as it'll go to the left and then have it drift back to the equilibrium position, which is not far. Because when you look at this K value, the K value very heavily favors the reactant. So the equilibrium should be very heavy this way. And just a little tiny bit of product. Did it stop?
No, it still goes. It's
okay.
good.
Okay, so if I make an ice table, there's my initial line. And I know the reaction is going to... This happened last time. Oh man. Out of ink. That's it. All right, so I'm going to have to come over here. Would you rotate the stool? Rotate the whole stool, if you will.
Hit the board.
Can you see it? Tell me if you can see this.
Can you see me?
Yeah, so you want to speak louder next? Hey, just go
I'm
up.
making this nice and big so everybody can see it. All right, is that on the screen?
Yeah.
Okay, awesome. Thanks, guys. So this was 0.0075, 0.025, and we know that the Q is greater than K, so it's going to shift all the way back this way. So we have the initial line. Now what's going to happen is we're assuming that it goes as far left as possible. That means one of these two reactants is going to run out. I say reactants, they are products, but one of these two is going to run out as it shifts this way. So that's going to go to 0, and that will go however much down by however much that goes down, which is that minus 0.0075, 0.0175. What I'm suggesting, and this is this modified idea, the modified ice table, we had an initial amount, but that went backwards to completion. So now I'm going to start a new ice table. And if you would, with me, just take a trip to the south. This modified, we're going to call it an ice table.
Downy outer.
So that's what we call a modified ice table.
Yeah.
An ice table.
He's actually from Texas.
Oh yeah. So let me hear it, Girish. Say it.
Girish, do it.
Say it.
Girish, do it.
No one says that.
Girish, do it.
Girish.
Yeah.
Show us your stuff next.
Represent your
Do I
Texas
actually
people.
kind of-
No, Girish, just do it.
Do it. I can't. I'm not. This is Southern.
Yes, you are. You're you were born in Texas, right?
No, he wasn't. He's born in Canada.
Oh.
Remember that barium sulfate, now let me have your attention, we're almost done with this. Barium sulfate is a solid, so we're not going to pay attention to how much there is. Just the fact that there is some is all that matters. Some was made. So again, a non-defined molarity because it's a solid. And now we're going to assume that it shifts back to the right. Now that this thing is 0, it can't stay 0. It's got to go back to the right. So that small amount of barium sulfate that was made, some of it is going to dissolve, and that's going to go up by x, and that's going to go up by x. So at equilibrium, it's x and 0.0175 plus x. The question is, what are the concentrations of barium and sulfate at the end? Can we neglect that plus x?
Yes.
Yes, in this case we can neglect that term because we know that x is going to be very small. How do we know that?
Because of the K.
Look at the k value, it's tiny, tiny k value. So that's what we'll just do now is we'll determine what that x value is, but it's not going to affect the 0.0175. I'm looking at 1 point, yeah, go ahead.
I
Helen.
think the K value isn't so tiny compared to the one we did before, right? That one was like 10 to the negative.
It does depend on how many ions are given off. Like the k value of that is kind of normal. When you have, if I take it back, oh, I can't take it back easily, but some of the other ones gave off 3 and 4 ions, and they were 10 to the negative 30 something. But when you take that, however many ions, that root of it, they're all pretty similar. Okay? So that is a part of it, is how many ions are given off as to how small that k value is. So this is how we set this last part up. Solving for x, we have x times 0.0175 plus a neglected x. And therefore we solve for x. We put that there. The SO4 we see, when we get x, it's tiny compared to 0.0175, so the final concentration of SO4 is 0.0175. What do you get for that, just so we have it?
8.6 times 10 to the negative
8.6 times 10 to the negative 8 molarity. And that is the barium. Tiny concentration. Hi. No problem. All right, I'm going to turn this off.